Hi guys, today I'm going to teach you guys about vectors. So the first thing you should know is the difference between, actually I don't know how I'm going to say this, but if I go from my house, right? My house, and then I go to school, right? Pretend the way to go to school is you have to go like this street and then take turn and then you're here, right? The total distance I go, and that's 5 miles, and that's 5 miles, and then the rest that's 10, right? That'd be 20, right? My total distance is 20. In physics, usually it's gonna be meters, right? But displacement is different because displacement is like the quickest line possible. So, and it's also final distance minus initial, and usually initial will be just zero. So instead of this, you'll have a little triangle, and this will be 5, this will be 15. That's going to be the hypotenuse, whatever angle, right? So I don't know if I'm going to teach you guys the simple trig stuff, because that's like, if you really need that stuff, like, comment it. But I don't think it's important for physics. Like, you should already know it, so I'm not going to go over it. But yeah, this but also you're supposed to, like, for displacement, since you're going in this direction, you're supposed to say due west or whatever direction it is, or like due east or whatever. Like, this is east, due east, and I think, right? Yeah, that's east. But yeah, so distance would be 20. It would be all this would be this plus this plus this. Displacement is just the quickest line possible. And here's another way to figure it out. If I go from my house and I go out to school, right? Actually, no, I'm gonna go back to this. Never mind. It is all gone. I go to school and I go back home and I and I go back to home. My displacement is zero because in total I moved like nothing. Like, in the end, I returned from the starting position, and displacement is just distance from the starting position. So if my starting position is here and my ending position is here, you would draw a straight line and then you would like do this to figure it out. And do a triangle. Here's a trick on these triangles. I will make it way easier, I feel like, to do these things. So this is the hypotenuse. This is the angle theta. And then this is the x coordinate. This is the y coordinate. And this is basically because sine, on, I don't know if you learned unit circle yet, but sine is basically up and down. Just remember that. And cosine is like right and left. On the unit circle, you will see that the sine of 0 is 90 and cosine of 0 is 1, but I don't think y'all know that yet, depending on how math class you're in. But just know for now that to find the x coordinate, you just have to do hypotenuse times cosine times theta. Theta is what this is called, by the way. And then this would be hypotenuse times sine and then the angle. And that's just a really simple trick which will allow you to like basically get everything done. So um I remember because I'm like a teacher assistant for AP Physics C Mechanics. I remember on the vectors test, I'll just make up these values. Actually, I'll do a practice problem first, and then I'll make up some values, and I'll do a test problem that was on the test or the quiz or whatever. So one displacement vector A has, so we first have to map out everything. A has a magnitude of 2.43. That's the distance. Magnitude is distance, and points due north. North is the direction. And then a second vector B has a magnitude of 7.74. It also points due north. So since this is super simple, they're both pointing due north. You would, so let's do the first one, A minus B. So you could, since they're both in the same direction, you could just do a minus b, like. But to do this, you could try to do it like, because you always have to draw it out. Drawing it out seems stupid right now, but in the future it'll be easier. So it goes up 2.43, and it's north, right? North, west, east, south, okay? And then it goes down 7.74. So you lose all this 2.23 extra stuff, and then you go down whatever extra stuff. I'm unplugging my laptop right now. And yeah, what could make it easier is pretending you're like on a GPS. It says first go down 7.74 kilometers and then move back up, right? That means all this distance is not counted, and they only see you that you move this much, because you start out from here and you end off right here. All right, I'm gonna do the test problem because I should probably get another problem from here. This has force in it though. I don't know if y'all. So it points east with 200 newtons. Actually, I don't think you need to even care about the force. And then a second force is added to it, and the resultant is 400 newtons. And then they point along the east-west line, and there are going to be two answers. The reason there's two answers is because there's no direction, so it could be 400 in this direction and that direction. So since you start off going 200, you can go 200 more, and that would be 400. And then you could just go like this, 600, right? 600 minus 200, because this is like, so you go from here, you go from negative 200, and you go forward 600, so then the total is be 400. Makes sense? But I don't think, but then I'm not doing the test problem right now. So it was like, I'm just gonna make up some random values. Okay, so 4, and then at 120 degrees plus 62 at 12 degrees plus 1 at 9 degrees, right? You really don't have to do anything. It doesn't really matter what these numbers are, because if you map them out all as a triangle, right? It's, so this is going 4, right? 4, but instead of going 4 like that, it's actually going 4 like that at 120 degrees. That's not actually 120 degrees, right? I'm just drawing it as a picture, right? So you can use the pattern sine, type sine theta, right? And the theta is be 120, and then you can just do that, and hypotenuse will be 4 sine 120. So you basically do that, and then I'm not going to do a whole for all of this. So you basically do x and a y. X is going to equal to 4 cosine 120 plus 62 cosine 12 plus 1 cosine 9. The same thing for y, but you switch cosine with sine. Sine 120 plus 62 sine 12 plus 1 sine 9. And you just take this y value, whatever you get as an answer, you put it in here, make a triangle. Whatever you get for the x value, you put it down here. So now it's going to be a triangle, right? And then you do the formula a squared plus b squared is equal to c squared. And so then when you take a square root, so you a squared is x squared plus y squared is equal to hypotenuse squared. And then you just cross out, you square root everything, right? And then boom, you got your answer. And that's how you do vectors.